There's something about the Golden Gate Bridge that makes it one of the most iconic bridges in the United States. I've always wondered why and how this bridge was built and what makes it so iconic. Now is the best time to answer those questions, as I'm currently a civil engineer that's been designing bridges for 2.5 years. First, we need to understand why the Golden Gate Bridge was even considered. The population of San Francisco grew quickly in the early 1900s, but development to the north was slow due to the mile-long Golden Gate Strait. The only way to get to the north was by ferry. There was a bunch of support for a bridge in the 1920s, as well as a ton of opposition from the ferry companies, conservationists, and even some engineers. Building a bridge over the Golden Gate Strait was Joseph B. Strauss's ambition, even though it was considered impossible at the time. He overcame many obstacles and assembled an amazing team of engineers, architects, geologists, and construction workers to design and build the bridge. The very first design for the Golden Gate Bridge was submitted by engineer Joseph B. Strauss in 1921. The original design was a hybrid bridge with the center suspension span supported by a cantilever truss at both ends of the bridge. The original design was deemed ugly by the local press, and I happen to agree with that statement. Fortunately, consulting engineers Leon Moiseff and O.H. Hamann convinced Joseph Strauss to switch the design to an all-suspension bridge design in 1929. The original design was much easier to design, especially without the help of modern computers and calculators. The all-suspension bridge design was much more complicated to design, as the calculator used during that time was called a slide rule. The drafting was also all done by hand using pencil and paper on drawing boards. Joseph Strauss assigned engineer Charles Ellis alongside Leon Moiseff to complete the calculations for the bridge. Recent advancements at the time in suspension bridge design theory were used to design the bridge. A steel tower model with a scale of 1 to 56 was used in testing to verify the calculations were accurate. The tall towers were designed in such a way that the honeycomb legs were strong but light. The towers were able to withstand the weight of the bridge transferred to the top of the towers through the cables, as well as resist earthquake and wind loads. The tower also had an Art Deco architectural style designed by architect Irving Morrow to add aesthetic touches with the use of chevron or beveled shapes. Construction of the bridge began January 5th of 1933. Of course, the greatest challenge came first, and that was underwater. The southern tower was located over 1,100 feet from the shoreline, requiring divers to descend up to 110 feet underwater. Dynamite was lowered into the water and positioned by the divers before being discharged. They used dynamite all the way down to bedrock and removed loose material with a high-pressure hose. Divers were also used to guide the forms and funnels for the concrete of the base of the tower. The divers dealt with cold water that was extremely dark. They were only able to work when the tide changed that lessened the currents, which only happened 4 times a day. The divers were constantly at risk of losing their lives as they were hooked up to a long hose that continuously pumped air from the surface. The base of the tower was protected by a huge oval-shaped concrete barrier that was built placing concrete through tubes underwater into wood forms. Once it was completed, the workers called it a giant bathtub, as the water within the concrete barrier hadn't been removed yet. 9.4 million gallons, or 35.6 million liters of seawater was removed, allowing the construction workers to place reinforcing steel and concrete to build the foundation of the tower. Reaching this location throughout the entire construction process was done using a temporary roadway that was struck by a freighter, as well as collapsed during a storm. Once the foundation was complete, the tower began construction in January of 1935, and it only took 6 months to build. The Golden Gate Bridge Towers were the tallest bridge towers in the world at 746 feet or 227 meters when construction on the bridge was completed in 1937. But how did the towers get constructed, as obviously the entire tower couldn't have been placed all at once? Smaller sections of prefabricated steel were lifted into place one by one. A crane was placed between the legs of the tower and was able to lift itself as the tower grew piece by piece until it was completed. The 44,000 tons of steel in each tower were fabricated at the Bethlehem Steel Plant in Pennsylvania and then shipped along the eastern coast through the Panama Canal up the west coast to San Francisco. With the towers completed, it's time to hang the main cables that will be transferring the tensile forces from the bridge deck to the towers. The construction of the cables began mid-1935. The diameter of the main cables measures about 3 feet or 1 meter, and the total weight of the cable weighed 12,000 tons. The cables were unable to be carried on barges and lifted to the towers due to its insane weight. Instead, the cables had to be constructed on site, high up in the air, using a process called cable spinning, which was invented by John A. Roebling's company in the 1800s. If that name sounds familiar, that's because I've covered him in my first 2 videos, as he was the designer of the Brooklyn Bridge. Dang, I might need to make a video specifically on John A. Roebling. Let me know if that's a video you'd be interested in. Anyways, back to the video. Construction workers pulled wire that was about as thick as a pencil from the concrete anchorage at one end up and over both towers to the other concrete anchorage at the other end. Once the wire was secured, it was sent back to the beginning and repeated over and over and over until 27,572 wires were spun for each main cable. Once the individual wires were in place, they were compacted together. This process took 6 months and 9 days, which set records for speed and efficiency. The deck on the bridge consists of steel trusses on either side of the roadway that support beams holding up the roadway, with vertical steel suspender ropes connecting to the steel truss every 50 feet. The deck was constructed outward from the tower in sections, making sure it's balanced. The final section of the bridge deck connected to the roadway on April 19th of 1937. During the construction of this bridge, safety was a high priority. The workers wore helmets, special wind goggles, and headlamps for the dark enclosed areas, which for some reason was a first in bridge construction. The paint of the bridge contained lead to prevent the steel from rusting, which we know now that lead paint is pretty bad for our health and is no longer used in the paints today for bridges. Construction workers also wore respirators to protect them from lead fumes during the installation of rivets. A very important first in bridge construction safety was the installation of a safety net that caught 19 men who fell. Unfortunately, the bridge had 11 fatalities, with 10 of them being caused by a heavy scaffolding falling through the net, causing the 10 men to fall to their death. While tragic, the number was low for the size of the bridge and the amount of the dangers that were present. And that is how the Golden Gate Bridge was constructed and why it's so iconic. In order for this bridge to last a long time, constant maintenance is needed, especially repainting the bridge to protect the steel from rusting and corroding. There have been several steel bridges that have collapsed due to neglect, with the most recent being the Fern Hollow Bridge in Pittsburgh, Pennsylvania. The Golden Gate Bridge was an engineering feat that broke many records at the time. The color of the bridge, which is called International Orange, is always used when repainting. I would love to cover more bridges, so if there's a specific bridge that you would like me to cover, let me know down in the comments, and make sure you leave a like on the video and subscribe to help me out.